Hi and welcome to this live demo of using Polygonica for mine excavation purposes. So first of all, I'm going to say this is just a proof of concept GUI that we've knocked up. I think it's based on WinForms or WPF, not sure which one. And in this case, it uses C++ CLI, but you can also use Polygonica's C# wrappers to program in C#. So first of all, I'm just going to load some terrain, and you'll see this is a .pgs file. That's a Polygonica format. We originally took the data in DXF and then tidied it up from there. The other thing I should mention, as you'll see, is that this data has been mocked up by ourselves. It's not real data, but it's based on real data that we've tested with Polygonica, but we're not allowed to show. So first of all, here's the terrain, and here's a partly mined opencast mine. And then I'm going to load the excavation plan, which is a set of curves. Again, we've converted these from DXF. They're actually in CSV format, but they're basically just polycurves. So if I look below the terrain, let's just see what we've loaded in. These are all different polycurves representing different regions that are going to be mined, or we're planning to mine, or that have been mined, depending on how you're doing it. So if I just hide the input solids and also the actual mine itself, then you can see this is what we've got. We've got a set of kind of 2D curves mostly, but you can see where there are ramps. There's 3D bits as well, so they're going up, they're going up along the side. You can see that there. And the general idea is we'll create extrusions of these, and then we'll subtract them using Polygonica's Boolean to do successive subtractions. So for those of you familiar with machine simulation and machine works, it's a very similar idea, but just working in mining rather than in CNC simulation. Okay, so I'm just gonna, there's a small adjustment there, and then I'm going to click calculate, and we'll see the, let me just zoom in a little bit more, we'll see the sort of simulation. So this is all the Booleans being done, and there we go, that's the result. So we did a very, very fast simulation of the mine being excavated. Now that's not really what's interesting here, so I'm going to show you more stuff we can do with this demo. But the first thing to notice is actually, look, there are these very, very thin polygons that have been left by the subtraction process, by the Boolean subtraction, and those arise because the polyline boundaries are not exactly matching, which is pretty typical in real data. So one of the things we can do is we can offset those slightly just to make sure that they do overlap, and then we get a clean result. So I'm going to start again. That's just the way this demo works. I'm going to reload in that landscape, and then I'm going to reload the curves. There we go. And this time I'm going to store intermediate results. And I'm also going to add a more significant offset for thin wall compensation. So this is going to run slower because we're storing, at each point we're going to store the intersection solid of the mine with the tool that's being subtracted, basically. So I'll do that. So you can see it's running a little bit slower here. And there we go, it's finished. And now we've got, you can see we've got a long list of operations here. So if I just, first of all, look at the surveys on the left, I've got my initial quarry, and then I'm just going to scroll down. And if you keep an eye on the 3D view, you'll see I can just scroll through to any point, and then I can scroll back up again, and I can jump around. So basically what we've done here is we've stored the mine at each interim point, and you can see that that's pretty effective to reload and display. And then similarly, let's say if we take position 14 and then load operation 15, and actually let's do it the other way around. So we want to load, say, 12, 13 and 14. So you can see we've got the intersection solids of the material that's actually removed listed here. So So you can look at those, examine them, you can slice them, you can figure out the volume, surface area, whatever you want. Basically, you've got a solid volume there that you can analyze. And that is basically it. Polygonica has a wider range of mesh operations, and you can use them very effectively in this kind of mining simulation. There's an accompanying video for this about mesh healing. So we're going to actually look at this terrain, because typically if you get a bunch of mesh data from a LiDAR scanner, you're going to have all kinds of things. You're going to have gaps, holes, self-intersections. It's going to be noisy. You want it smoothing, etc., etc. So we'll show you how Polygonica can do that in a separate video. If you want to learn more about Polygonica, check the polygonica.com website out. There's a contact form. You can get in touch with us, or you can find us on LinkedIn. So please don't hesitate to say hello and ask any questions you'd like to ask. And thanks for your time, and thanks for listening.